of chapter 4, that is measurement of voltage and current. The next concept is moving iron instruments. Still now in this chapter I discussed about PMMC instrument. Now we'll start with the moving iron instrument, that is MI instruments. Okay. This 4.2 is moving iron instruments. This moving iron instrument or MI instrument, again there exist two types of moving iron instruments. One is attraction type instrument, okay, attraction type moving iron instrument. Okay. Another one is a repulsion type moving iron instrument. Yes, a repulsion type moving iron instruments. In this repulsion type, again two types based on the shape of iron piece we are using in the instrument. Shape of the iron vein, iron piece we are using in the instrument. These are again two types. One is radial vein repulsion type instrument. Yes. Another one is coaxial vein repulsion type instrument. One is radial vein and other one is coaxial vein repulsion type instrument. Attraction type, repulsion again based on the shape of iron piece. Radial vein means if use the shape of iron piece used in the instrument is like this, then it is nothing but a radial vein. What the coaxial vein means, if the shape of iron piece used in the instrument is like this, then it is nothing but a coaxial vein. The shape of the iron piece is like this, then it is nothing but a coaxial vein type instrument. Okay, based on the shape of iron piece we are using. In this, first I want to give construction details like what I explained in PMMC. Then based on the construction details, we can get some idea what exactly MI type instrument, what mechanism it is having. Then based on the construction details, I will list out some points. Whatever the points I will list out, that is important to answer any theory question based on the MI instrument. Then I will derive what the torque equation of MI instrument, what the observation from the torque equation is also important. Then I will explain how to convert MI as a ammeter, how to convert MI as a voltmeter. Then after that we will solve the classroom workbook questions. Okay, these are the concepts I want to discuss in moving iron instruments, that is MI type instruments. Okay, first I will draw the construction details of both attraction and repulsion type instrument. Okay, then I will explain operation, then we can list out the points. Okay, you draw the construction details of both attraction type and repulsion type instrument. See, the first one is attraction type. The construction details of attraction type instrument, so that you concentrate. Attraction type instrument. Yes. What are the construction details of attraction type instrument? Yes. In attraction type instrument, this is the shape of magnet we are using. We can use H-shaped electromagnet. We are using one H-shaped electromagnet. S, the shape of magnet. This is one electromagnet representation. Okay, then okay, this is winding representation. Yes. Okay, this I am representing as a winding. Okay, now this current entering and current is leaving. Entering is cross. Okay, current leaving is dot. Okay, now this consists of a mechanism of spindle like this. Please. This is spindle with jewel bearing suspension. This is jewel bearing suspension. Yes. Then we are using spring control provided with air friction damping. Spring control. Then we are placing soft iron disc. This is one soft iron disc. Yes. There is a pointer and scale arrangement. This theta, this deflecting torque. Whenever deflecting torque equal to controlling torque, then the pointer comes to steady state. Okay, this total mechanism put in this box. Then it becomes a moving iron instrument, attraction moving iron instrument. Yes, this attraction moving iron instrument. Yes. Then whenever supply is switch on, there is a current flowing through the coil. Then this is current is leaving. Yes, the direction of current is like this. Okay, then this is electromagnet. Electromagnet. And this is soft iron disc. Okay, this is jewel bearing suspension. Yes, jewel bearing suspension. Jewel bearing suspension. We know that generally how we are represented electromagnet. An electromagnet is represented like this now. This electromagnet is represented like this. This is a representation of electromagnet. Okay, then current entering, leaving, current entering, leaving, entering, leaving, entering, leaving, entering, leaving. This also, that same electromagnet I represented like this. This current is cross, means current entering, leaving, entering, leaving, cross dot, cross dot, cross dot, like that I have represented. Okay, this totally, this is the shape of the electromagnet used in attraction type instrument is, this is H-shaped electromagnet. Okay, H-shaped electromagnet we are used. Okay, the simply this total mechanism put in this box, then it becomes a moving iron attraction type instrument. One observation here, we are allowing current through only coil. We are not allowing the current through springs. That's why in moving iron instrument, springs not carrying the current. That this total is also represented like this. Simply this arrangement is also can be represented like this. This moving iron attraction, moving iron instrument is also represented like this. This is electromagnet. So represent like this. Here we are placing the coil. Here we are giving AC supply or DC supply. It is used for both AC and DC. Then flux is produced. In this magnetic field, we are placing one iron disc. This is iron disc, soft iron disc. We also represent like this. Now see, what is the operation of this attraction type instrument? How it can work? How it shows the reading? Later on I will give the repulsion type instrument. But what are the points I will list out? That points are same for attraction and repulsion type instrument, but only the operation will be different. Okay, this works on the attraction, but repulsion type will works on the repulsion principle. Okay, that we will see later. Now listen please. Whenever supply is switched on, it may be AC supply or it may be DC supply. We can give the AC supply or we can give the DC supply. This electromagnet will be magnetized. Yes sir. For AC supply also it will be magnetized. For DC supply also it is magnetized. Electromagnet is magnetized means there is a formation of north pole and south pole, or it may be a south pole and north pole based on the direction of current. Whenever this electromagnet is magnetized, it produces attraction force on the iron disc. Yes sir. Because the force between iron disc and electromagnet is always which force? Attraction force only. But the force between two magnets, it may be attractive or repulsive based on the pole formation. But the force between iron and magnet must be which force? Attraction force. That means this electromagnet produces attraction force on the iron disc. Whenever AC supply is given or DC supply is given, it produces the attraction force. But actually this iron disc is, this is spindle. Practically the arrangement is like this. This is spindle. The iron disc is fixed to spindle. This iron disc is fixed to spindle. But this electromagnet is producing attraction force, but this iron disc is fixed to spindle. Because of this force, the iron disc will not move like this and it cannot attach to the magnet. Why? It is fixed to spindle. But still it is producing force, but it is not moving and it is not attached to the magnet. Now finally, because of this force, it is not moving like this, it is not attached to the electromagnet. Because of this force acting as a twisting force on the iron disc, because of the twisting force, the iron disc starts to rotate like this. Yes, sir. When the iron disc is rotating, because the spindle is fixed to iron disc, along with iron disc, the spindle is also rotate. Yes. When the spindle is rotating, because pointer is fixed to the spindle, along with the spindle, the pointer is moving. When the pointer starts to moving, because of elasticity property of spring is wound in opposite direction. Whenever deflecting torque equal to controlling torque, then the pointer will comes to the steady state, then the meter shows the required reading. Okay, that is the operation of attraction type instrument. Clear? Understand or not? Okay, this is the operation. Very simple. Once again, what I am telling, whenever supply is switch on, this electromagnet will be magnetized. It produces attraction force on the iron disc. Once it produces attraction force on the iron disc, that force acting as a twisting force on the iron disc, then the iron disc will rotate. Spindle is also rotate. Then pointer is moving on the scale. Whenever deflecting torque equal to controlling torque, then the pointer will comes to the steady state. Okay. But you have the doubt here. Sir, you told that whenever AC supply is given to PMMC, because of average torque is 0, then meter cannot show the any reading. Now the question is, sir, how this meter shows, how this meter can work for AC supply? Very simple. Whenever alternating supply is given, during positive half cycle, this electromagnet will magnetized. Let us assume that initially pointer is at 0. During positive half cycle, this electromagnet will be magnetized. Then it produces attraction force. Because of that force, pointer is moving. How it is moving? Spindle is rotating. That is, iron disc is rotating, spindle is rotating. That's why pointer is also moving. Suddenly, whenever negative half cycle is came, in the negative half cycle also, this electromagnet will be magnetized. No? Yes, sir. Once it is magnetized, means, let us assume that initially it is a north pole, south pole, means it is south pole, north pole. Poles will be changes. But always it produces which force? Attraction force only. Because of that attraction force, again pointer is moving in the same direction only. That's why, even though it is an alternating supply, always torque is in one direction. Once the torque is in one direction means, then pointer is continuously moving. Whenever deflecting torque equal to controlling torque, then the pointer will comes to the steady state, then meter shows the required reading, hence it works for AC. Understood or not? Because of whenever negative half cycle is came, is it produce repulsion force? No. Always it produces which force? Attraction force only. Because it is a magnet, that is iron disc. Then because of that force, always pointer is moving in one direction. Whenever deflecting torque equal to controlling torque, then the pointer will comes to the steady state. Sir, again doubt. Sir, it is a electromagnet. Electromagnet is nothing but one inductance. Then how this work for DC? That is meaningless. Don't think like this. DC supply XL equal to 5FL, F equal to 0. How it will work? Like that, no need to think. What you want the concept here? Production of magnetization. Magnetization. Can you give the AC supply or give the DC supply? No problem. This electromagnet will be magnetized. Then it works for both AC and DC. For AC supply also it is magnetized. For DC supply also it is magnetized. Once it is magnetized, it produces attraction force on the iron disc. Because of that attraction force, the coil is the disc is rotate, spindle is also rotate, pointer is moving on the scale. Whenever deflecting torque equal to controlling torque, then the pointer will comes to the steady state. Okay, that is the operation of what exactly attraction type instrument. This concept can also be analyzed like this. Listen please. Internally, this instrument works on the principle of hysteresis principle. What do you mean by hysteresis principle? Means whenever AC supply is given, then it produces the magnetic field. Whenever it produces the magnetic field, the iron disc always try to align to offer the low reluctance path. That means this iron disc is continuously rotate in such a way that it offers a low reluctance path. Try to align in the low reluctance path. For example, field lines are moving like this, then iron disc will be like this. The field lines are moving like this, then the iron disc will be like this. If the field lines are moving like this, then iron disc will be like this. If this iron disc is not present, what is that path? Air path. Air is the medium, means it offers high reluctance. Always it try to align in the, it offers low reluctance path. If you want to offer low reluctance path, means that flux lines must passing through iron core. Then in order to offer the low reluctance path, always the iron disc will be rotating. Then always once the iron disc is rotating, pointer is also moving on the scale. Understood? That's why it works on hysteresis principle. Always the iron disc will rotate in such a way that try to align to offer the low reluctance path. Low reluctance path means high inductance path. L equal to N square by reluctance, N square by reluctance. If it offers low reluctance, means it offers high inductance. That means it try to align always iron disc according to hysteresis principle. According to hysteresis principle. Hysteresis principle. The iron disc is try to align in the low reluctance path to offer, try to align in the low reluctance path. In the low reluctance path. Low reluctance path. Low reluctance path means high inductance path. It offers high inductance path. Like this, the iron disc will rotate. Iron disc will rotate. But point to remember, here we are using the iron disc. The magnetic path is iron disc path. Always the flux lines are passing through iron disc. When the magnetic path is iron disc path, means then it offers high hysteresis losses. Yes or no? If the magnetic path is iron disc path, means then it offers more hysteresis losses. If it is a air path, means it offers the less hysteresis losses. But this is iron path na. Hence practically, in order to reduce the hysteresis losses, whatever the electromagnet we are using, it is not iron core electromagnet. We can use air core electromagnet. Understood? That's the construction you follow. Whatever the electromagnet we are using, already iron disc is there. You also use electromagnet is also used some iron or steel core we can use. That also will offer hysteresis losses. This will offer hysteresis losses and this also will offer hysteresis losses. The hysteresis losses plays more. That's the reason why, in order to reduce the hysteresis losses, whatever electromagnet we can use, then we can use air core electromagnet. Air core electromagnet. Because of air core electromagnet, the flux allowed, the flux lines produced by the air core electromagnet is less. Because of this reason only, the flux density in the case of moving iron instrument is very weak magnet. That is very weak magnetic field only we can produce. Why the very weak magnetic field is possible in the case of moving iron instrument means because of using the air core electromagnet. Once we can use air core electromagnet, the very weak magnetic field is produced as compared to PMMC instrument. In the case of PMMC instrument, what the range of flux density I told? 0.1 Weber per meter square to 1 Weber per meter square. But in the case of moving iron instrument, the magnetic flux density is 0.0062 Weber per meter square to, this is very, very weak magnetic field, 0.0062 Weber per meter square to 0.0075 Weber per meter square. Why this much of weak magnetic field is produced? Because we are using the air core magnet. Sir, why you can use air core magnet? In order to reduce the hysteresis losses. Otherwise, already iron disc is there. Because of that iron disc, already that instrument offers some more hysteresis losses. You also made with some, core is made with some silicon steel or iron core you can use. It also offers hysteresis losses. The resultant hysteresis losses are more. In order to reduce that only, we can use air core magnet. Because of that air core magnet only, the flux density offered by this moving iron instrument is very less. When the flux density is very weak, then you don't apply eddy current damping. In the case of moving iron instrument, I told already now, wherever we are applying eddy current damping is, to apply the eddy current damping, the magnetic flux density will be more. That strong magnet is present. If the strong magnetic field is present, then only we can apply eddy current damping. But here, eddy current damping is not possible because of very weak magnetic field. Then which type of damping you can use in the case of moving iron instrument? Then we can use, yes, we can use the air friction damping. Understood? Okay, this about what exactly attraction type instrument. How this attraction type instrument can work. Internally, it works on the principle of hysteresis. Always the iron disc will try align in the low reluctance path. It offers. Always try to align for the flow of flux lines. It offers the low reluctance. When the flux lines will, for the flux lines flow must be low reluctance, that flux lines must allow through the iron core. Then only reluctance is less. Understood? Like that the iron disc will rotate. Okay. This about moving iron instrument, that is attraction type instrument. Here I want to list out the points. What are the points I will list out here? The same points will applicable for repulsion type instrument also, but the operation of repulsion type instrument will different as compared to attraction type instrument. Name itself, it works on attraction principle, that works on repulsion principle. Okay, you list out some points. Tell. TD is produced by which effect? Electromagnetic effect. Yes, TD is produced by electromagnetic effect. Electromagnetic effect. What about TC? TC is produced by spring control. Yes, TC is produced by spring control. Range of flux density. Range of flux density in MI instrument. That is 0.0062 Weber per meter square to, yes, 0.0075 Weber per meter square. Is the range of flux density. Why this weak magnetic field? The reason I told already. Then because of weak magnetic field, yes, because of weak magnetic field, yes, because of weak magnetic field, air friction damping is used. Yes, air friction damping is used. Because of weak magnetic field, air friction damping is used. Tell me, it is a polarized instrument or unpolarized instrument? Yes, it is unpolarized. Whatever the supply, it may be positive or negative, always torque is produced in one direction. That is, it is unpolarized instrument. The reason, you know, unpolarized instrument. But PMMC is a polarized instrument because based on the direction of polarity, the direction of torque will be reversed. But it is not the case. Always torque is in one direction. That's the reason why you seen in the laboratory also in MI instrument you don't have any plus minus. There is only common and range terminals. You interchange common and range terminals, no problem. Always pointer is rotating in one direction only. It is unpolarized instrument. Yes. It is used for both AC and DC. It is used for both AC and DC. But if any instrument is using for AC means frequency range also important. This moving iron instrument, it is used for a frequency range of 0 to 125 Hz. These are more preferable for 0 to 125 Hz only. But you know that it is a very weak magnetic field. In the case of MI instrument, it is very weak magnetic field. Because of its very weak magnetic field, if any external magnet is bring to the nearer to MI instrument, this electromagnetic field will be affected. That's the reason why practically this moving iron instrument is shielded to protect from stray magnetic fields because of very weak magnetic field. Practically it is provided with shielding. It is magnetically shielded to protect from stray magnetic field, external magnetic field, stray magnetic field, because of very weak magnet. Okay, practically it is magnetically shielded to protect from stray magnetic field. Okay, then one more point to remember. It is more preferable. Practically it is more preferable to measure AC and DC voltage, to measure AC voltage and current, not DC, AC voltage and current. For DC measurement already PMMC is there. Among all the instruments for measurement of AC voltage and current, the more preferable instrument is MI instrument. Among all the instruments, it is less cost. MI instrument is less cost. It is less cost. And this MI instrument is more preferable in the application of panel mounted instruments. In panel mounted instruments, then which is more preferable is MI is more preferable for panel mounted instruments also. Practically which is more preferable? MI instrument is more preferable. Okay. Then what is the purpose of using jewel bearing suspension? Jewel bearing suspension is used. A jewel bearing suspension is used. Jewel bearing suspension is used to reduce frictional errors. Is to reduce frictional errors. To reduce frictional errors. Yes. Very important statement. Based on this statement only we can solve the classroom workbook questions also. It is RMS measuring and RMS indicating type instrument. It is RMS measuring and RMS indicating type instrument. Indicating type instrument. That means whatever the input is applied to MI instrument, then what it measures? It measures the RMS value. But you see in PMMC, whatever the input is applied to PMMC, what values it measures? Average value. But MI means which values it measures? RMS values. Then this MI instrument is having high overload capacity. High overload capacity. If any high voltages or high current allowed through the meter, beyond that rating also, it is having the overloading capability, that is high overload capacity. It can withstand that high currents and high voltage also. High overload capacity. Okay. And this is about what exactly? TC is produced by spring control and springs not carrying the current. That point also remember. But in the case of PMMC, springs is carrying the current. But here springs not carrying the current. And springs not carrying the current. Okay, this about in detail what exactly moving iron instrument. This attraction type instrument. For repulsion type instruments also the points are same, but operation will be different, that you will see later. What is the operation of repulsion type instrument? Okay, this total mechanism put in this box, then it becomes a moving iron instrument. This is soft iron disc, means a high permeability steel material we can use. A soft iron disc, we can use high permeability steel material, and it is also soft iron disc we are using. Then iron disc, in the sense we can use some iron material, some alloy combination also we can use in order to reduce the which losses? In order to reduce the hysteresis losses. In order to reduce the hysteresis losses only, we are using the soft iron disc. Okay, then we can use nickel plus iron combination, that gives the soft iron disc. Understand? Okay, this about in detail about attraction type instrument. Understand? Concentrate these points. Quick note down. Okay, in the next session, we'll continue with what is the operation of repulsion type instrument. Then I will give some differences between attraction type and repulsion type instrument. Then after that, we'll start with the deflecting torque equation of MI instruments. Okay, clear? Understand? That you concentrate these points. Thank you.